Hello, hello, hello. Ah, we're on. The timing did work. Cool. Hey, everyone. How's your NDC been? Cool. Anyone here's first NDC ever? Hands? Whoa, whoa, whoa. Okay, okay. How many of you recognize at least one of these games by the screenshot, by the way? Just about all of you. Okay, awesome. How many of you came here to learn about gaming-related stuff? Cool. A couple of you. How many about accessibility? You're here to learn about accessibility. How many of you are like, oh my God, he said .NET and AI, let's go? A lot of you, yeah, awesome, awesome. And how many of you wanted to see me bomb about JavaScript questions again like I did last night? A few of you, yeah. Well, there's no JavaScript here today, which means I get to be a little bit smarter. But to get started here, I'm Alex Dunn. You'll find me on the internet as Suave Pirate, if you don't know that already. If you've been to one of my talks before, this is an old story. But my name is Alex Dunn. It's a very ordinary name. And when I started sort of getting, setting up my internet presence and all that good stuff, I was like, okay, let's do all the different Alex Dunn variations. Alex Dunn Developer, Alex Dunn Developer 2, 3, 4, 5. Okay. I work in the Microsoft stack a lot. There are 3 now Alex Dunns working at Microsoft, 2 in .NET. So I used the name generator I wrote when I was like 10 years old, adjective, noun, and Suave Pirate has stuck. Even though some of them are underscores, it's fine by me. But I'm the chief product officer at a company called Voicify. We do SaaS, voice AI, platform, stuff like that. And I also founded a company called Enabled Play, which you'll learn a little bit more about today. But essentially, it's an assistive tech company for people with disabilities to make everything a little bit more accessible. So really, the whole point of this talk is a lot of different things, really. It's a story about how we sort of got to where we are with accessibility, varying different ways of thinking about accessibility, why it matters, things like that. And it also gets into the nitty-gritty of applying AI, building machine learning models, using them the right way, getting all the latest tools, doing it in .NET, using Azure, and a few other things. And we'll get into the details, but I want to start really by kind of talking about accessibility and why it matters. And for me, what really drove me into applying AI for accessibility. So one of the main issues we have, both in Europe and in the States, and really in a lot of sort of Western and actually really global cultures, is we introduce technology at younger and younger ages now, which is a great thing. We introduce it at ages of like 3 and 4 in school. There are preschools and kindergartens and first grade, second grades where they're on laptops already. They're learning how to type, they're learning how to use stuff. And it's an amazing thing because the earlier we introduce tech, the faster we all can sort of move together, and students can do amazing things with technology. Anyone do any like robotics clubs in like middle school, high school, anything like that? For us, this is huge in the US, at least in the Northeast where I'm from in Boston. There's this group called First Robotics, and it's a big competitive, it's global now, robotics competition. There's technically 3 different ones depending on your different levels. And it's amazing now, as I'm someone who mentors and volunteers there, to watch kids as young as like 8 build robots and basically write code. And they do all sorts of amazing things. But kids also start to use technology at younger ages to socialize. We live in a society that's always on, as frustrating as that can be sometimes, and us as software developers are partially responsible for making that type of society, but kids now are even more involved in that sort of always on, which is okay. There's social impact things. We're not going to really get into that. But with all these different things, and the more we introduce technology at younger ages, a lot of times we don't stop and think, what if that student can't participate in that technology from that younger age? What if they're debilitated with a disability? It doesn't have to mean they can't do it at all. It could be something as minor as, I have hand tremors, so typing and learning to type is a little bit harder for me than it is for my friend. We introduce technology at younger ages, but we also then start to introduce these problems of accessibility immediately. And we create a systemic problem when we do that. Now, who's responsible for this systemic problem? Is it us? Is it software developers? Is it technologists? Is it teachers? Is it just society in general? No, it's this guy. He did it. This is Christopher Latham Scholes, and he made the stupid QWERTY keyboard layout on the typewriter hundreds of years ago now. And basically everything in terms of the human-computer interaction paradigm has developed out of this stupid QWERTY keyboard layout, which even like mathematically isn't even optimal anymore. Anyone have like vertical or horizontal listed keyboards now that are like technically faster, but you're like breaking your fingers to get used to it? Well, we didn't make the problem, this guy did, but we can solve it. So how do we solve this problem of accessibility being introduced as an issue, or lack of accessibility being introduced as an issue to kids at younger and younger ages? It's with video game violence. This is the way we do it. Just an actual warning, we're going to play some videos and stuff with some actual video game violence, mostly like first-person shooter, RPG stuff, relatively harmless. We try to kind of take it back a little bit, but it's there. So if you're of the faint of heart and are not really cool with video game violence, I'll let you know when it's coming. All right. Some of you said at the beginning on that first slide you know at least some of those games. Anyone recognize this screen? I can't really see. Okay. A good number of you. A good number of you. If those that recognize it have probably seen it a lot. Because this is the most common screen that people see in a game called Dark Souls, or really in a whole series of games from this group called From Software. And Dark Souls is widely considered one of the hardest games in a series of games that's been built. It's a massive, massive skill gap. It's really punishing. It requires you to be extremely persistent, get perfect timing with everything, learn all the moves, and just repeat, 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 repeat until you finally beat it. And then you get that ultimate satisfaction of like, I finally beat that boss that I was stuck on, and then you get punished 30 seconds later afterwards. So I set out to basically start with accessibility by making Dark Souls a little bit more accessible. It's the hardest game for people with disabilities. It's one of the most popular games, and they're like, we can't play this game no matter what. Even with new input devices, we still can't physically do it. It's not our fault, so why can't we make this game more accessible? So my first thought, well, what if I build an AI that can help play Dark Souls for me / with me? It doesn't have to be, a complete sort of cheat, but I want to use AI to actually play this game and make it a little bit easier, which is a pretty crazy concept. And so we're going to talk a little bit about this crazy concept to working software journey together and all the L's we take along the way, just so that you don't have to go through the same mistakes and deal with virtual inputs and all that good stuff. So some rules we have for this challenge, I guess, of making Dark Souls more accessible, building a bot to play Dark Souls. So we can't hack the game. Because that would only work on PC, and it also wouldn't work across any other games, which is another rule. So the concept has to actually function across these different games, and it has to work. So first thing I started with, I have a background in computer vision. I was going to do some computer vision and do some image recognition on the screen and realize, oh, we're about to get attacked. Someone's about to hit us. Let's roll, or let's counterattack in certain scenarios. It doesn't have to be perfect, but to supplement some of those hard and fast-paced moves. And so basically, it looks like this. This is that screenshot from Dark Souls 3, and basically we start labeling just tons of data. We go through multiple playthroughs, we're labeling things all over the place. This is a big scary sword that's being swung at us, and our cool guy is in danger, so now we should recognize this sort of state using this computer vision model and roll out of the way. Actually a pretty straightforward concept. The problem is that you're more or less always in danger in a game like Dark Souls. Like I mentioned before, it's extremely punishing. It's not just punishing to you as the player, but when you're trying to run a computer vision model against a game that is hopefully running at 60 FPS, normally it's capped at 30 for the original Dark Souls, is you don't just cook your brain, you also cook your GPU. So I quite literally burned an entire GPU, unusable. I couldn't even sell it to the miners and like get some pity money out of it. It was done. Trying to play high definition game while also trying to use the same GPU to do inference, not so successful. So something a little bit smaller model. Let's do combat music detection. Basically, we hear scary music. Let's just start, I don't know, randomly dodging a little bit here and there, right? You can get lucky with that. Problem is, there's always kind of in combat. It's the same issue, really. And then, as someone who rages at games because I'm an emotional person, if you can't tell already, I was sitting there playing Warzone. This is back in 2020 when Call of Duty's Warzone just came out. I was playing with some of my friends, and I was like getting super frustrated because it felt like everyone was hacking, everyone was cheating, and it wasn't just me being bad. It couldn't be that, no. So I thought, well, what if I could actually just say the things where I'm like, I said open the door, I said vault, and it actually would do that. Something like this, where I'm screaming, serpentine, serpentine, serpentine. And I've got a background in voice AI and speech recognition, so I was like, I can do this. I need somewhere to take voice input. I need a microphone somewhere. I need to be able to network in order to send microphone-related data somewhere to do speech recognition and to send a command to my computer. And I need to actually fire a command off. And so this looks a little bit like this. I'm a user. I'm talking to some device. In this first example and some of these code snippets, we're going to be doing it with an Alexa speaker, which I know. You're like, why would you do that? It's literally so much harder, and you have to say so many more things. But I had one on my desk, and I was like, I want to yell at Alexa, and have it play Call of Duty for me. And so we did that. It goes to the voice assistant service, goes to a centralized API that says, hey, you said reload in Call of Duty. Therefore, we should send the command down to press the R key on a keyboard, and then something needs to press the R key. So basically it looks like this. On the API side, we're just handling an HTTP post request. We get a skill request. That's just an Alexa body that they send along, which has an intent. It might have some of the natural language understanding data. It's not really important. In the end, all we were looking for was mapping like an intent name to a key or to an action. So things like reload, things like put on armor, things like shoot or attack should just send that somewhere else. And so we're using SignalR, and we're just blasting, hey, Alex said reload. Someone handle this on the client side. And now over on the client side in a little Windows app, I believe we did in UWP first, which was admittedly a mistake. We connect to the same SignalR hub, and then we just subscribe to those events. When we get reload, we use this virtual key, and we try to press the key. In this case, it's either 4 or 0, whatever you're trying to do. I think armor is actually 4, and that comment's wrong. It's like, great. I put it in Notepad. We're seeing all the numbers come up, and all the clicks are happening, and everything's great. So we jump into the game, and I say this super long statement just to shoot. Alexa, tell the Warzone controller to shoot, which if you've used Alexa is also not even a reliable thing because sometimes that just doesn't work. But then nothing happened. I was like, this was just working. It was working in Notepad. Okay, maybe it's an issue with Call of Duty. It was actually even scarier. I thought that I got banned from Call of Duty because it was doing nothing. All of a sudden, my keyboard stopped working too, and I couldn't get into any multiplayer games, and it started crashing. Every time I was loading up with this thing debugging, it would crash the game, which is actually not me getting banned. Pro tip, don't play any Activision Blizzard game and run the Visual Studio debugger. For some reason, they actually conflict. Pro tip. So we tried some other games. We went back to Dark Souls. We tried Sekiro. And none of those worked. Same thing. The guy's just sort of standing there waiting to do something. Then someone in my Twitch chat at the time where I was streaming building this was like, oh, try this web-based game called Crunker. And that kind of worked. So we tried a whole bunch of other things before we got to what our solution is. We were using this input simulator, input virtual simulator to simulate keys and mouse movements and stuff like that. Some other things we tried based off of everybody's suggestions of like, well, this definitely will work. WPF and send keys doesn't work. WinForms and send keys doesn't work. I don't know why that would be different, but someone was like, I know this will work in WinForms because I do WinForms, and therefore WinForms and send keys works. Can't run extended background tasks. That wasn't the issue. And we also couldn't do anything USB over IP. No matter what, nothing happened in any of these games. And then I was introduced to this little guy, a little piece of hardware. This is an Arduino Leonardo. And it's unique because it actually registers itself as a human interface device, a HID device, HID, as a keyboard and a mouse. And you can also sort of set it up to register as a game controller too. But you can actually talk two different ways over that USB port. You can send serial commands over it, which we'll talk a little bit about. But you can also receive that USB back over. Plus, it's got a way cooler name than Virtual Input Simulator. We're using the Leonardo now. So now our architecture looks like this. We still send everything to this Windows app, but the Windows app is now sending serial commands to a physical device, and then the physical device is sending stuff right back out. Super hacky, I know, but it works. You can hear Alexa responding in the background because you can't not respond when you receive an Alexa request. So that's why she's like,
Alexa, tell Warzone controller to shoot. Okay, chat, we need you guys to get one headshot. That way we can at least get the highlights. So someone's got to start shooting. Take a shot. Take a shot. There it is. Oh!
okay, it works. There is something there. We can actually play games with an Alexa speaker somehow. So now we need to go from this concept of working software to a real product. And this is, what I do a lot. I work in product development. So I wanted to take a look at what other people are really using, what's out there. The most popular thing for adaptive gaming specifically, although it's used all over the place, is this tool called the Xbox Adaptive Controller. Anyone heard of this before? Anyone used it before? It's amazing, really. So if you can't really tell, let me see if I can get this highlight thing working here. Woo, okay. So there's a USB port here. There's another one on the other side. And then all along the top, there are 3.5 millimeter jacks. And they map to every single button on what a normal Xbox controller is. So you can plug in a custom button and mount it however you want, and now you're able to hit that button. You can bring custom joysticks. Take, like, for example, a lot of flight sim joysticks. You can actually plug that in, and use that just like you would use a thumb joystick on an Xbox controller. Well, now people that have issues with fine motor control can use more gross motor control to actually play these games. But it's still not enough for fast-paced games, for competitive games. Take, for example, my friend here in your top left, my top right. He has his Y button, that little yellow button. It's mounted on his headrest on his power chair. So the same distance that I need to move my thumb, which is less than a millimeter to activate the Y button on a regular controller, he's got to move about 6 inches, hit a button, and then come back. It's amazing for games that are simple or they're slower paced, but when you're talking about a game like Dark Souls or like Call of Duty, where speed matters and other people will beat you, it's accessible, but it's not equal. And that was something that was really frustrating for me. There's also other tools out there. In Xbox, you can use Cortana for voice commands. You can't use it in-game, because that would be cheating, kind of. There's audio navigation. There's co-gaming, which is cool. So you can have 2 controllers control the same person on Xbox, which is nice. So like, if you're using an Xbox adaptive controller, you can have a person next to you also supplementing your inputs. In multiplayer games, there's skill-based matchmaking, but for those who play, know that that doesn't really work super well. And some games have game difficulty setting. Dark Souls isn't one of those. There's also amazing organizations who build on top of this tech, and they help people get the most out of it. Some of our partners like these, the Able Gamers charity in the US, Special Effect out of the UK, Warfighter Engage, which works with injured veterans for the exact same purpose, Cerebral Palsy Foundation, Conquer Paralysis Now. There's so many people out there that are just trying to take the tools and adapt them to each individual's use case, because everyone's disability is different. So there's still a need, right? We can't just say, it's solved. Accessibility in gaming is done. We're good to go. Everyone can compete violently just like I can. So let's talk about how we scale solutions in order to continue to solve the problem. Because I don't know if you remember back in that Signal, our hub call, I was calling all clients. Everybody's going to know that I'm reloading and do something with it, which when I'm just running one Windows app in my one little web server, that's totally fine. But if we want to let people sign in, manage their devices, and handle their own commands, we need to scale things out. So taking this diagram, ignoring the hardware side of it, because it's just buy more devices, we need to be able to handle multiple users. We need to be able to handle multiple voice services. Not everyone's got a little Alexa puck in front of them that they get to play with. We need to handle the actual different assistants or different platforms that people are going to play on. We need to handle the different desktops, and we need to handle more than just Call of Duty. So let's talk quickly about how we actually scale out these types of solutions. So for handling voice services, again, this is what my company does, so that was just easy. For scaling out the different applications, I went with Xamarin, and now it's moved over to Maui, just because I've always used Xamarin. I've also used React Native, and I've used Flutter, but I love the ability to get to lower level stuff with tools like Xamarin and with Maui. That is a little bit harder to do on Flutter and React Native for things like sending serial commands or managing Bluetooth connections or handling background events properly. We can abstract all the UI to one solution and have all the individual native services do what they got to do. So now we need to handle multiple users, which is authentication. We need to put up our walls around our service so that I know you're the same person on the left as you are on the right, so that when you say shoot, it's not shooting on your computer, it is shooting on mine. So to handle logging in from both sides, we need to log in from the app. You sign into your Windows app, you need to create an account. In the case of doing things with Xamarin, there's already tools built in. I didn't even have to figure out the client side of OAuth and token management. Xamarin Essentials and now it's actually just built into Maui. It literally has a built-in thing where I just say, here's my URL, please do the OAuth, thank you. Now, of course, we have to do the OAuth on the back end, and we still need to figure out the voice service side, which is more complicated. So I don't know if anyone here has done anything with voice assistants like Alexa, Bixby, Google Assistant. Siri is its own thing. We don't talk about Siri. And tried to authenticate a user. It's quite a process, and it's a process called account linking, because you're not just signing in, you're linking your account to your Amazon account or to your Google account. And there's a lot of extra steps. But basically, the voice assistant needs to receive a response from you as the developer to say, you need to log in now. And we're going to return a card that says, please log in. The user then goes to the app. They have to leave the speaker, awful user experience, go to the app, see, oh, I got a login card. Let me log in with my account. Pulls up the web page, they sign in, and then there's a whole bunch of different token transfer stuff. The cool thing is they handle refresh tokens and everything else, but if you're not built perfectly to the OAuth 2 spec with Pixie support, you can't do it. So here's basically what the setup looks like for adding the bearer token and some of the refresh token stuff on the ASP.NET side that we did. Again, this is just using built-in middleware from ASP.NET with add authentication. We register our signing key that we're using for decoding the bearer tokens, the actual access tokens that are sent whether it's from Alexa or whether it's from the mobile or desktop apps. And that way we can just throw authorized tags on really our one endpoint that's handling the request. And then from the client side, this is using that Xamarin Essentials library, where again, we just take whatever that URL is to do the login, and we fire it off. Cool. So now we need to personalize things and make it a bit easier. We build keyboard profiles. We can now map any voice command to any button. We can also do things like add macros, which is a great tool. It's not just shoot and it clicks a button. I can say slide cancel in Call of Duty and do a combination of things with perfect timing. We also need to be able to make it not as super slow as you saw in that video of Alexa tell Warzone controller to shoot. Right? It's awful. It's not actually useful at all. We do things like action queuing, jump, 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 space, space, space right away. We don't have to wait for the full sort of speech to get processed. So here's what it looks like to send things over serial so that we actually execute those commands now with action queuing and all this good stuff that's built out. This is the last step to finally being able to have people sign in, have them open the app, have them plug in a little Arduino Leonardo, and be off and running. From the Windows side, we just send a serial command, which is basically sending a string. There's more things happening underneath, but eventually we send this, like you can see at the bottom, press space 500. What command is it? What are the parameters? And we separate them by spaces. And so then on the Arduino side, we receive that command. We say, hey, we got press. Let's go into this subfunction, this subroutine. And now we need to extract all those arguments. What was the thing that they said to press? It was space. How long should they hold it for? 500 milliseconds. Great. So now that we have something that's functioning, what I did in this case, and I don't know if any of you have done hackathons before, but we competed with this on the development side. So we submitted a solution. I say we, me and Twitch chat, submitted to 2 different Microsoft hackathons, got second place in both, and we added things like Azure Cognitive Services to do the speech recognition. You don't need the stupid puck. You don't need Alexa. You don't need Google Assistant. You speak to the same desktop app or even to a mobile app now using your microphone. We're using Cog Services to do speech recognition, and then it just sends it all through that same exact API because it's all abstracted away. It's just send a string. What do we do with this string? So here's what that looks like, as well as with some computer vision stuff too, which we'll talk a little bit more about because there's a better example of it with Snapchat.
All right, hopefully it continues on the one we just did and not our new game +4. Attack.
Oh, it's so slow still.
There you go. Oof. Block. Ooh, attack.
Oh, yeah.
Attack.
That's like a whole 3 seconds.
Ooh, that was actually done in time. Attack.
Okay, it's fun. It works. We don't have to have a speaker anymore. We're not saying, Alexa, tell the Sekiro controller to attack. I'm just screaming attack over and over again. Now, this is one of my favorite ones. Now, bear with me how I explain it. Does anyone here use Snapchat? Anyone familiar with Snapchat? Anyone here use like Instagram filters and stuff instead of Facebook filters like via your camera? Because that's really all you need to know about this. For those that don't know Snapchat though, it's a social media app. You take pictures, you send them to people and they delete themselves after, but they have this amazingly powerful camera software and these tools that you can actually build as a developer called lenses. So if you've ever worked with something like Unity, they have a lens studio. It feels exactly like Unity. It almost feels like they cloned it or forked it and then just started doing it with lens stuff. But we turned Snapchat into a controller so you can use your face and your voice at the same time. So like I said, bear with me while I explain it because it's really, really hacky. You have a mobile app. You tap a button. It opens up Snapchat with the lens. So now you're there. You're in the actual Snapchat app. The lens is looking for face expression changes, opening your mouth, raising your eyebrows, hand gestures, horns, one finger up, fist, things like that. And it flashes QR codes on the screen because you can't send HTTP data. You can't make web requests out of Snapchat. That would be scary if you could. So we're just flashing QR codes. So we built another Windows app, which is now reading your phone's screen, which you have to now plug your phone into your computer, by the way, and make sure you have everything set up where it can actually like stream the screen. We use the screen reading APIs to stream it. We use zebra crossing to read the QR codes. And we go, oh my God, we got a QR code. We should do the thing. Map mouth open to this command, and it's all now part of the system. I can just say mouth open is spacebar, for example. So here's what it sort of looks like in Fall Guys, a lovely little game. And you can see basically on the left is Snapchat. Those empty squares of the different QR codes are going to flash. And then this is just me with an anime filter on, which is also powered by Snapchat. But you'll see we'll do different things to basically trigger things in game, and this is fast.
Every time I take a jump, I'm gonna have to like keep my coffee down here so I don't have to use my hands. So I'll be like, all right, this is a good one. I gotta like, I'm gonna end up like doing like this and like punching my coffee.
You see the QR code's flashing now?
All right, we're playing
Wait for it.
one-handed. So I'm gonna keep my other hand here so I can just be like real quick. Just to see if it's working, I'm gonna use my eyebrows. Little jump, little fist, jump. There's the jump dive. All right, we're off and running. Double jump. Please.
Now, I'm actually not good at Fall Guys. It's not the fault of Snapchat. That's just me being uncoordinated. But pretty cool. That was fast, right? You see the little eyebrow raises going on, and I'm jumping along, which is cool. And I was playing with one hand in that case just to have the other hand for doing just gestures and stuff like that. I basically just had a hand on a joystick, and that was the only thing that was moving it. We also built, and there was a little bit of a sneak preview of this in the previous Call of Duty video, a Twitch bot, so that my chat can actually press keys in my games for me. They just send things like exclamation point press shoot or press space, and it will actually execute in game. And this is another Windows app that you sign into with the same account. You link your Twitch account, and then it's reading every message that comes in. There's some delay just because Twitch's chat is not actually real time, and it's not a consistent delay either. But take a look here in the video, right above that side of me is the chat. You can see people spamming press whatever, and you'll basically they're doing all the shooting and everything else, plus Snapchat.
How's the delay on chat now? Now to open reload. Jump. Just hold. Come on. Oh, here we go.
Moments before doom. So now there's really something there. We're playing with our voice, we're playing with our face, we're playing with our hands. Everything really should be an input control, which is why we created something more formally around it called enabled play. Now, of course, there's still some things that are really slow. Voice was tragically slow there. Even still, attack. Boom, okay, useless. So we needed to clean up a couple things. We needed to fix performance, that was a big one. We needed to handle privacy. Right now, that's streaming your face to Snapchat, or streaming your face to Microsoft, or we had a version of it that was sending it to Facebook. All wonderful companies that will use your face for ethical reasons. I don't know if anyone here has used COG services in production. I'm a big fan of COG services, but if you had, for example, 10,000 people using this, it's not an absurd number, a great number to get to, and they're using face expressions in voice, and it is constantly streaming their video and trying to process face expressions against COG services, we calculated the bill would be between $30,000 and $150,000 a month to run this thing. That's a little bit too much, and it still didn't really scale that well. So let's talk about the speech recognition, which is obviously the worst performing thing. This is sort of the way that typical speech recognition software works, and this is the way that we were implementing it with COG services. Something starts streaming the audio and recording it. It could be that, hey, we detected volume change, so now we need to start actually recording it. We hear your voice, let's start recording it. We record the whole chunk of audio, and then we send it up to some service somewhere, Azure COG services or any other speech recognition tool, and then we get whatever the string is that came out of that. But we also have to know when the person stopped talking in order to know that we need to actually send the command. Alexa, tell Warzone controller to shoot. Wait 500 milliseconds, then send all the audio, then get the string, and then do stuff, which is why it's super slow. So instead, we went with a new offline model, and now we're finally going to talk about doing machine learning offline, which is fun. So instead, we do something that's more predictive in real time, and it's offline. It's actually built into these now production devices, which have two different far-field microphones. So they listen just like ears, and it's actually doing all the processing now. It's on a Raspberry Pi compute module. But we take the audio, we're constantly streaming it, we're constantly checking what the user is saying, and we're leaning into what they want for voice commands. I don't have to process all of your speech. I only care when you say something that you told me you want to say in order to run the speech recognition to fire a command. And we can do that extremely fast. So the fastest I ever got that standard speech recognition with COG services for the jump, this is like with action queuing and all this like crazy optimistic stuff that we were doing, is 1.5 seconds. That's not that bad, and that's actually like pretty reasonable for like any use case that's not gaming. But with predictive ASR offline, we're actually hitting it once every 10 milliseconds. We're saying you're going to hit the space bar because you said jump before you emphasize the P sound, because we know what you're going to say because you told us what you want to say, and so we can lean into it. Also, like I said before, on the privacy side, just like how we were streaming face, we also need to stream your audio, which means if you're going to play this with games and you're going to leave it in your living room for hours at a time, and you're going to send exactly what you're saying, every conversation, everything else, to a speech recognition service, it doesn't feel so good to do that. But now we can actually take that offline as well. So we get to scale back the pricing because it's all offline. We're not paying COG services. We're not paying any Facebook APIs. We're not using Google speech to text. It's all running offline. And we now get to cut back on our overall server costs because more of the processing in general is done entirely offline. Basically, same thing for expressions, like I mentioned before. It works similarly where we need to now be recording your entire face or whatever your camera is that you're using, whether it be through Snapchat or through the app itself using your webcam. We need to take that and every single video buffer, every frame of your video, go send it to a cloud service, be like, recognize the face, what's the face position right now, what should we do, are the eyebrows raised, should we actually now execute a command? And when you're streaming a video at 60 frames per second, and you're trying to calculate all those changes, and you're constantly streaming it to someone else's service, that's where it gets slow, and that's where it gets really expensive too. So we did that offline now. And I'll talk a little bit about how you can also do this with tools like Onyx, which we're going to get into, and using different, basically the Onyx runtime to detect face expressions in any app that you run. So here's what the full platform looks like. There's still an online service so that you can use a phone to communicate to your PC, but all the actual AI is running on the edge. So now, the only thing I really have to do is say, tell this device to start listening, by sending it still over SignalR, authorized against this, which is also connected to the internet itself. I don't need another app running on my desktop, one of the 10 that we put together. And then on the receiving side, I basically just listen for it and say, start the speech recognition. It's as simple as that. And then it sends back and says, hey, I've started listening, and we just update the status back in the app to say, hey, they're listening now. Cool, we've got two-way syncing. So here's another example now with this all put together, face expressions, voice, body, tilt controls, all sorts of cool stuff. And this is a very simple one with Minecraft, and I'm going to over-explain it because it's going to go fast. We can do combinations of face expressions, left wink, then right wink, and I did that backwards, but maybe to you it looked right, to run a macro that changes it to daytime. I use voice commands to just start running forward. I smile to open my inventory, and I can even run a macro to build a 3x3 block by just saying 3x3.
Go. Three by three.
Cool. I can pre-record macros. I can share them with you, so now you can go take them and use them. You don't have to go through the effort of figuring out how to do it elsewhere. But here's how it all sort of comes together. You sign into an account. You create the profiles, just like we did in the old ugly example where we had that big pink keyboard mapping. But this is how you say, this is what I want to map to what. So I want to, when I smile, hit the E key to open my inventory in Minecraft. Whereas when I'm playing Call of Duty, maybe I want to smile to reload or smile to shoot. I can raise my eyebrows. I can say any voice command in any language that I want to be able to support, including support for nonverbal speech recognition. So we're going to go through a little exercise here because it's always hilarious. But there's this interesting thing with voice where we have this sort of, I guess, idea that voice needs to be words in order to communicate because that's how we do it. But there are many people out there who can't enunciate words, but they can make sounds. And so there's this interesting study that's been done out of the University of Washington, which was sponsored by Microsoft and Google as well. They call it the tongue controller. And it's for people that can move their tongue, but they can't move their mouth. You can actually make 9 different vowel sounds out of that. So think about it like this. You just make a constant sound, and then move your tongue, the tip of your tongue up to the roof, or the middle of your tongue, or the back of your tongue, or any combination of that. And now you've got basically 9 different movements without even moving or even opening your mouth, which is fascinating. So I can be like, and it's literally just moving my tongue up and down. It's pretty cool. So feel free to try that and enjoy all the weird sounds that you'll find yourself making when you're moving your tongue around. We can also do things like tilt controls, where we can take a phone or a tablet and start tilting it to move. That can be like moving a mouse or moving a joystick, which is great. My favorite thing that I've seen some kids use in school is they'll use the shake detection, and it's just mapped to delete. and they'll just like rage quit whatever they were writing by shaking their tablet. I gotta find a video of it with someone that'll give me permission to put it up here, but it's pretty funny. Expression controls will use your webcam or your phone camera. We're distributing the compute, not just on the computer where you're playing the game or using the app, but any device that you have at your disposal to do things, same eyebrow raises, head tilting and moving too. So being able to move your mouse by moving your head, or move a joystick by moving your head, or even just like triggering commands by looking left and right. You can also build virtual buttons. One of the things that, going back to the Xbox adaptive controller that I said, is having to lean your head or move your hand up and over to a pad with gross motor controls to physically hit a button is significantly more work, where you can have a massive tablet screen that just needs a single tap of one mega button in order to run as a command, which is pretty cool. You could have literally an entire iPad, and if you just slap your hand on it, that can be a command. Or you can add 100 buttons, and they fill out this little grid, which is cool. We also can now use our phone and tablet keyboards as our laptop or desktop keyboards. Tablet keyboards and phone keyboards are extremely accessible compared to this physical thing. I get swiping, I get dictation. I can put all these things together now with tilt and voice and face and virtual buttons and still have any other physical control I want to play games. So here's what it looks like in our latest craze of Elden Ring, which, has anyone here played Elden Ring, I guess? Big fans? Yeah, I love it, naturally, as a Dark Souls person. It's sort of like big Dark Souls. Which has also been a big sort of craze around, like, is it accessible? It's technically more accessible than Dark Souls because you're not as stuck all the time, but the inputs are actually harder. You have to do things like, for example, if you want to mount or switch weapons, which you have to do like in the middle of sort of getting whipped around, you have to like hit triangle or Y and then up on the D-pad while you're still using your joysticks, and like you kind of do like this weird claw movement. I was sick of that, and so I made basically voice commands for all of it, and I'll show you a quick video of that here.
Sneak. Attack. Dodge.
That's right, we got good and parried with our face. Okay, you get the point. We got it. A lot of this is powered offline by tools referred to. Really, it's a whole suite of things called Onyx. Anyone used Onyx before? Anyone heard of Onyx? No? Okay. Some of you have heard. No one really used it, which is great. We're gonna talk about it. It's kind of the whole point. We're actually gonna do some .NET AI stuff. So Onyx is the open neural net exchange, and it's a lot of different things packed into one. Conceptually, the most important thing to note is that it is a consistent way to use models across platforms. A lot of times, machine learning is done in Python. Anyone here a Python dev? Anyone here strictly anti-Python? More anti-Python people than actually enjoy Python. Cool. So many of those tools are there, which means it's intimidating to get into. You got to learn this stupid language with no brackets that makes no sense, where white space matters. But Onyx lets you actually take pre-built models that built in PyTorch, built in TensorFlow, and convert them into one that can run anywhere. You can run it in .NET. You can run it in the browser in a lot of cases, as long as it's small enough to be able to be packaged up and downloaded, because some of them can get pretty big. So we're going to do a little bit of a walkthrough. But before that, I want to show you how this thing actually comes together. And if you have your laptops out, you can feel free to compete. And whoever does basically complete this challenge, write a function that prints 0 to 100, write a function that adds a button to a page that, when clicked, runs that loop function, and then run the function that adds the button to the page. Relatively simple thing, but you get to use your hands, and in this case, we don't. So let me switch over. I've got a video version of it because I'm also going to be using AI like GitHub Copilot to put everything together. And this is not showing up for you guys. We're going to, I'm going to have to switch presentation mode soon because this is not great.
Open code.
That's right, from scratch.
Comment. Type create a loop from 1 to 100. Enter. Function. Tab. Enter. comment.
I have to see it down here, by the way, which is...
Type add a button to the page, and when the button is clicked, run the loop function. Enter. Function. Tab. Enter. Comment. Type run the add button function. Enter. Tab.
Sweet. Pretty quick. Okay. Let's go look at some of the computer vision stuff. And I'm going to try to do it this way so that we can actually... Oh, boy. Okay. Let's talk about Onyx. So I'm going to pull up the website real quick just so you all can see it. Hopefully the internet will be forgiving. This is Onyx, onyx.ai. Again, amazing tool. On top of being the runtime that's cross-platform so you can run these models, there's also a huge open source community of people converting very popular models into things that you can run locally. Has anyone here heard of T5 or T5X or T5v1.1 and all these ridiculous names that machine learning people give these models? This is a model that came out of Google Research. It's relatively new. They're already onto their second version. It's called T5 because it's like text-to-text transform of something. There's another T in there. But essentially, it's very much following the same text transformer pattern as GPT-3. Anyone heard of GPT-3? OpenAI's big, like it's going to take over the world, powering things like GitHub Copilot, an amazing feat of machine learning powered by or built with hundreds of billions of parameters and cost millions of dollars in infrastructure to train. Well, T5 we get for free. We can actually run it everywhere, and it does very similar things. You can do specific tasks. You can do things like translate, which is one that I have up open here right now. And you can actually go to this Hugging Face URL. Just look up Hugging Face T5, honestly, and you'll find it. And we can do things like compute a translation. In this case, it's doing it from English to German, I think. I don't speak German, so I'm assuming that's what it is, in insane amounts of time, offline. In this case, it can actually run it in the browser, which is insane. But T5 can be used for all sorts of things. You don't just do text-to-text like translation. You can do text-to-task. We can do things like take a macro. Take that build 6x6, and I can just say, run a macro that does this, and I've trained a model to be able to output just a simple JSON array of these different move the mouse this way, click this way, and it's able to start creating macros on the fly, which means I can just say what I want my computer to do, and it'll actually do it by using this text transforming. Cool thing is, T5 has already been ported to Onyx, which means you can use this in .NET. But enough on the voice stuff. Let's talk a little bit more about the face expression things. I want to show you this simple sample of using this face landmark model with Onyx in .NET. So this is in .NET 6, just a console app. And what you'll see in the code is we just get all images from a directory, basically current directory backed up a bit to /images. We initialize this face detector, which is going to download the model, or not download, it's already downloaded, but instantiate the model, unpack the model, and then we can start feeding stuff into it. We also initialize this painter because you'll see as a result that we can actually paint on the picture to show the landmarks. So if you're not familiar with facial landmarks, this is what we use in enable play to know that you raised your eyebrows or that you tilted your head or that you opened your mouth. And essentially it's a series of points around your face. We detect all the edges of your face, we detect the edges of your lips, the edges of your eyes, your pupils, and your eyebrows. And it's just an array of points, just X and Y coordinates based off the image that you feed it. And so the whole goal of this is take a whole folder of images and then just go paint where all those points are on the faces of the people in the picture. So here's what it looks like. We loop over each of our files from that folder. We then instantiate a new bitmap for each one of those files because we need to get to the pixel data. We then get the file name because we're going to be reusing that later to save the same file in a different folder. We then crop it to the specific size. Usually for really any machine learning model, it's computer vision. It's best when you're using a consistent size. In this case, it's usually like 224 by 224 pixels. So you kind of like find the face and then crop to the face and then detect the landmarks within it. And then we just get that list of points from the model extractor, all offline. We grab the points, we throw it in the paint data, we redraw over the image, and then we're done. So I'm going to do this a little bit on the fly, and we're going to see how it goes. I'm going to take a picture of myself with my camera, and then we're just going to drag that image over. Hey, hey. Cool. beautiful little picture. There it is. We're going to copy it. We're going to go put it in that images folder with other pictures of my face and other people's faces. And then we're going to go run this. Cool, we did it. We ran all the faces, including my new Windows face. So now let's go to the results, which I'll pull up over here. And if I open up this one, we might need to zoom in. You can see all of these little points on my face. Detected. It took milliseconds to do this. So every time we're running against the camera feed, offline within the app, we're able to detect all these landmarks, detect changes within them, and then translate those to the human interface side. Anyone here cool with me taking a picture of you as a crowd, or anyone not cool with that? I'm going to see if we can find all your faces, even if it's dark. Anyone? We cool with it? Everyone cool? Let's see. This is obviously has not really been stress tests like this. We're going to see how it goes. Where's my camera? Did I close it? It's me again. Okay, guys. Oh boy, that light. Let's see who's going to even get picked up. We're really going to stress test this. Beautiful. You guys look great. Okay, back over here. Take your lens flare picture. Don't need to do that. I need to go to the other one. Back to images. Paste it. We're going to run all of them again just because that's the way the cookie crumbles. And we'll just spin it back up. It might take a little bit longer. There's going to be far more faces than one in this. Oh, no. 0 faces, no. Sorry, you guys actually just don't have any faces, I guess. Well, that was fun with the lens flare. That's okay. So let's look a little bit more into how we actually extract the model itself and do all the actual sending of the data to detect faces and do stuff with it. So this is that actual landmarks extractor. In this case, this is actually a different implementation than the one in the .NET 6 one because this is running in UWP. That's right, even UWP can run Onyx. So the only things you need to do is install the Microsoft.ml.onyx runtime NuGet package. And it just requires .NET Standard 2. You can literally put it in Xamarin apps, you put it in mobile apps, you can put it in Blazor apps, you can run it on the client side. And even if you're not doing .NET, there's obviously Python libraries for Onyx, there's JavaScript libraries for Onyx, there is Kotlin and Java libraries for Onyx as well, because the Onyx runtime, again, is meant to be able to run everywhere. Let's look at what actually happens, right? Because we call that forward method, which is where we actually do the logic of extracting the faces. So in this case, we actually resized to 112 by 112. So not the 224, I was wrong. I was off by half. So we take that big image of all you all, and we had to really refine it down to each one of the faces. So we find the faces with a different model, and then we take each one and we crop your faces into 112 by 112 pixels, and then we need to resize it. In this case, again, UWP, we're using software bitmaps, which is tragic because they're significantly less utility than a regular bitmap, and UWP does not support system.drawing for almost anything. Even if you use the other library, it can't do it, but whatever. So we get the actual now cloned version of the image. So we create a copy of just your face, just your little 112 by 112 face. And then we basically create what's called a tensor. Anyone here familiar with tensors at all or TensorFlow? Cool. I'm going to simplify it a lot here. Essentially, it's just, in this case, it's floats. It's just a matrix of floats. It's a 2D array of floats. Sometimes you can do 3D arrays. And essentially, it's just describing each pixel in this case. Each one of those pixels in the 112 by 112, we need to know what is the color of it so that we can actually send that to the model, because the model's not really reading an image the way that we do as people. It's reading data. So we send it that list. We define basically this 3 is going to be how many things representative in each one of that 112 by 112 because we have RGB or BRG, I think in this case. We create the tensor float, the tensor of float. So you can see here the actual type is float array. We got a 2D array of floats. We then just send that to the model using this Onyx runtime session, passing in that input. And then what we get back out is dependent on the model itself. And so if you ever find an Onyx model and you're like, okay, it's going to send me back another matrix of floats and floats, how do I actually interpret that into real data? There's an amazing tool, which I don't know why it's not coming up, called the WinML something or other. where you can drop in the Onyx model, and it'll show you on the left side what you need to send it. So there's that 0, 3, 112 by 112. That's what this is the model we're using, and what it's going to output, which in this case is a series of points with X and Y. And you can actually even sort of, I know it might be a little hard to see here, we'll zoom all the way out, even look at somewhat the kind of business logic as to what the model is going to do. So for things like text transformers, they're usually actually a little bit simpler. They do tokenization, they pull stuff out. For image and computer vision stuff, there's a lot of things they do to like manipulate the image data, extract it into chunks, process them in chunks, which is why we've got a couple different branches going on here. And I'll zoom back in just to give you an idea. Not exactly readable as anyone as like a .NET developer, like what is going on. The main thing I look at is like, what do I need to send it and what does it send back? So you can always go download these open source. Usually they're MIT licensed. Sometimes the data underneath them is not, so you need to be careful with that. And we just pass it in here to take a look at it. And so now that we get our results back, we get a list of confidences over the floats. So hey, we've got points. And then we just turn those into a point of X, Y, and Z. Not Z in this case, but you can do some stuff with like 3D based like things with pose detection, all that good stuff. And then we just dispose everything because we're using a lot of unsafe code underneath with the library. We have to dispose the session if we're not going to reuse it. We need to dispose the image data because that takes up a lot of memory. Think about it, if we took a picture of all of you and we actually could get the 112s of each of your faces. We've got like, I don't know how many of you there are, 50 maybe people, and we have 50 images in memory at all times. Got to clean stuff up. And then you send it back up and you do whatever you want with it, which is how, in this case, now going back over here, all we do is just draw points on people's faces. So I'll open up a couple other ones of these so you can see like ones with groups, for example, although yours wasn't going to work. Here's a selfie group. This isn't me. But you can see each individual person actually got their points on their face. And the more we zoom in, the more terrifying it gets. Look into his eyes. Cool. So, come on, slides. Help me out here. Slides. Slides, come back. We'll go back to extend. Maybe that'll help. Oh. Oh, I think I broke it. Oh, boy. I actually think PowerPoint's crashing. Oh, yeah. Okay. It's all going down. Whoa. No spoilers. What I wanted to do, just to sort of wrap up and leave some stuff with you, is obviously doing things with Onyx is cool. It's actually incredibly simple. I'm going to try to figure this out real quick. We're going to try to duplicate again, and I'm just going to shift F5 from here. Oh my gosh, you can see all my actual slides. No, oh no. Is it Shift F5 to go from current slide? Are we up? Oh, there we go. I want to give you some quotes from people that are using Enable Play and why. Like, in the end, it's a lot of cool AI. It's a lot of cool tech. And it's fun to blow stuff up in video games by yelling at it or raising your eyebrows to jump in Fall Guys. But again, going back to what we're doing when we're introducing tech and creating these systemic problems, this is obviously not the full solution, but it's something that is continuing to inspire me to develop, push the tech a little bit further. I'm just going to go through a couple quotes here real quick. This is from one of our users who uses it in writing code with his voice. But I'm getting old and my typing skills are falling apart. It makes it difficult to maintain a train of thought when I'm busy staring at the keyboard. Anyone else have that problem? Even like if you're just tired and you're like, oh, I missed something, now I got to take a step back. Trying to hit the correct key. I use Enable Play so I can get better at programming again. This one, our son Jackson is paralyzed from the shoulders down, and he uses Enable Play to play games with his brothers and for his schoolwork. Another one, my son has a genetic disorder, CTNNB1 syndrome. I don't know what that is. As I'm sure you know, school is all on the computer, like we were saying earlier. He's unable to use a computer like every other kid because of his fine motor control. It's very weak. Starting next year when he's in middle school, he'll be doing everything on a computer. I see success with this, so he can actually participate in school activities with a lot less stress. And this one, to be more independent, to actually use my computer or other devices without pain or aching, and to be able to play video games with my boyfriend and nephews. I just want to leave you with this. we have tools to build things that really help people. It's never been a better time to be a software developer. You don't actually have to pay a lot in cloud services for things that you might otherwise expect to. We can run machine learning models that do incredibly powerful things for free. There are so many amazing things we can do with them as .NET developers like myself, or really as any developer building applications for people. So I hope you'll join me in building things that make a difference in people's lives. And with that, thank you. And I'm here to take questions or comments, or if anyone wants to try yelling at my computer to play a game, we can always do that too.